In the diagram, parallel lines M and N are cut by transversal T. Identify all pairs of alternate interior angles. Alternate interior angles are on opposite sides of the transversal and in between the parallel lines. Identify all pairs of corresponding angles. Corresponding angles are on the same side of the transversal and in the same location on the parallel line. So for example, angle 2 and angle 6, they are both on the top right of their parallel lines. There are several. You need to identify all pairs. If the measure of angle 1 is 128 degrees, what is the measure of angle 2? This creates a straight angle, which has a sum of 180. So you'll need to calculate that to figure out how much is left for angle 2. If the measure of angle 1 is 128, what is the measure of angle 8? These are alternate exterior angles. What do we know about alternate exteriors? Dylan claims that the diagram shows the image of AB under a dilation with center O. What do you notice about AB and A prime B prime? If we were to draw a line connecting O, our center of dilation, with these points, I notice that those points fall on the line, but A prime is farther away and B prime is closer. I also notice that these segments intersect. Do you agree with Dylan? Explain. I do not. No. A was dilated by a factor greater than 1. Which makes A prime farther away. And B was dilated by a factor less than 1. Since it is closer than the original. If they do not have the same scale factor, then this is not a dilation from center O. Summarize how to draw the image of a segment under a dilation. Well, we would start by drawing a line through the points. And the center of dilation. Then we would dilate each endpoint of the segment. And then connect the images. Okay. We have an activity on lined paper that we are going to do. So I'm going to switch to the document camera. The first thing to consider is, what do you notice about the lines on this lined paper? all of the lines on our lined paper are parallel. As we proceed through this activity, we're going to use these features of the lined paper to apply a dilation. The other thing that is helpful is that they are all equally spaced. On the first line of your paper, you are going to mark a point and label it O as our center of dilation. From center O, use the edge of your transparency or the edge of your ruler to draw a ray that extends down and to the left and goes across at least 5 lines before it reaches the end of your page. Count 2 lines down from O and mark a point where the ray you have drawn crosses the line and label this point P. So here's 1, 2 lines. We're going to put a point here and label it P. Now count 5 lines down from there and mark the ray where it crosses the line and label it P prime. So 1, 2, 3, 4, 5. P prime. What is the center of dilation? The center of dilation is O. And where is it in comparison to point P? They are on different lines of the lined paper. Do we know the scale factor? Not necessarily, but we do have some information we can use to conclude a prediction about the scale factor. We know that since P prime is farther away than P, that the scale factor is going to be greater than 1. In our previous lessons, we used a ruler to find the distances between points. Earlier, I referred to this lined paper as a tool because it's evenly spaced and all those lines are parallel. How can those features be helpful in finding the distances? Well, we can think about those distances between the lines or the spaces between the lines similarly to how we use the coordinate plane or a coordinate grid. So we can say from O to P is a distance of 2. And from O to P prime is a distance of 5. So we can determine our scale factor by using our formula from before. I mixed those up, but I realized my mistake because earlier we said that the scale factor was going to be bigger than 1. So OP prime was 5 and OP is 2. So we're dividing both sides by 2, which means R, the scale factor, is 5 over 2 or 2.5. Starting back at center O again, we are going to draw a line using our straight edge that goes down and towards the right and at least goes 5 lines. Count down 2 lines on that ray and label it with Q. Then count down 5 lines and label it with Q prime. Determine the scale factor of the dilation that maps Q to Q prime. Show your work in the right-hand corner. Earlier we said that O and P were on different lines, but how do P and Q compare? P and Q are on the same line. O and Q are on different lines, but P and Q fall on that same line here. The scale factors are also the same. So do you think that we found the images for both points under the same dilation? Well, yes, we dilated from the same center, and we used the same scale factor. So these are the images of these points here. Now we can determine the image of a segment by using lined paper. We can see what happens to a regular segment, PQ, under a dilation. Where do you think the image of a third point would be under the same dilation centered at O with a scale factor of 5 and 2? So if we put another point in here and labeled it A, it would be on the same line as P and Q. So then A prime would be on the same line as P prime and Q prime. We see that A prime is on the same line as P prime, Q prime, and A was on the same line as PQ. So if we continue to place more and more points in between P and Q and dilate them, we would see that they would continue to fall on the same line. So since the image of PQ and P prime, Q prime all fall on the same section, we can say that PQ corresponds to P prime, Q prime. So we can draw this segment in here. Because we know that if we continue to dilate points in the middle, the same pattern would hold true. So every point in between would fall on this line. When we dilate a segment, such as PQ, under the dilation, we discussed earlier that all of the lines on our lined paper are parallel. So when we dilate a segment like PQ, the image will be parallel to the original. Do you think there is a relationship between the length of PQ and P prime, Q prime? Well, there is, because if we multiply the length of PQ by the scale factor, it will give us the length of P prime, Q prime. So some key features: the segment grows at the same rate as the scale factor, and the segments will be parallel to each other under a dilation. Another thing that's helpful in this drawing is we have two parallel lines cut by transversals. So we can say that these angles are corresponding, and we know that corresponding angles are congruent. This angle here is corresponding with this angle because these are two parallel lines cut by another transversal. So this angle and this angle are congruent by corresponding angles. So now that we have the fact that dilated segments create parallel pieces, we can use that information to help us with the angle measurements as well. Make sure that your warm-up is filled in, your workbook is filled in, and that you have your lined paper drawing completed for this lesson. Again, the two key takeaways are that these segments are parallel when they're dilated, and that impacts the angles involved in the drawing.